right, so let's start with exponents. And of course, we have to start with some vocab. Okay, vocabulary. So we're going to start with what everything is called. So the whole expression is called a power. Okay, the whole 7 to the power of 2 we call a power. The 7 would be our base, and that is the big number that we have here at the bottom. And my 2 at the top, which is my small number, would be called an exponent. Okay, so does anyone know what this means? What does the exponent tell you? It says 7 to the power of 2, but that 2 tells you what? What exactly does this mean? Does anyone know? Anyone willing to share with us their profound knowledge? I should probably, there we go, spotlight. Anybody know what the 2 means, what that exponent tells us? It has a very specific meaning, right? So 7 to the power of 2 would not mean the same thing as 7 to the power of 3. What is the difference between those two things? Anyone? I know you guys know. Let's not be shy. Come on, come on. Multiply. Thank you very much, Entle. Okay, it tells you how many times you are multiplying this number by itself. So 7 to the power of 2 means there are 2 of them. So this would be 7 times 7, which means 7 to the power of 3 means there are 3 of them. Okay, we are not multiplying the base by the exponent. So 7 times 7 is not the same as 7 times 2. Okay, do not make that mistake. You will lose a lot of marks if you do that. So let's get started. This is the law we are starting with today. It's called the product law. What does product mean? We should all know what the word product means. If I say find the product of 2 and 3, what am I actually saying to you? Anyone? Product means what? Multiply. Thank you, Kirani. It means we are multiplying. Okay, so if we multiply 2 powers that have the same base, I'm going to highlight this because I catch you guys out every time, with the same base, then you can just add the exponents. Okay, so let's see what we're saying here. We have a to the power of m and a to the power of n. So if that is the case, you keep your base a, and then you add the exponents, which we have over here. Okay, now let's apply this law a little bit so that we make sure we understand what we are saying here. Oh, before we do that, I want to see if you guys have gotten a hold of my vocab. Okay. So I'm going to go ahead and fill in this table with your help. So for the first one, we have a 2 to the power of 3. So that's the first of our vocabulary. The whole expression is called the power. 2 to the power of 3. What is my base in this case for the first one? The base is 2, and my exponent is 3. And what is the value? What is the answer for 2 to the power of 3? 8. Nice. Okay, we're off to a great start, but I would like more of us to participate in the chat, please. I love it when you guys are just your answers. Okay, let's try the second one. We have a 4 to the power of 2, my base. Nice, Kirani. We have a base of 4. My exponent, 2, and the value of it, it is 16. Remember, 4 to the power of 2 means 4 times 4, not 4 times 2. Okay, these are not the same. Okay, let's go to the next one. We have a 5 to the power of 6. What is my base? 5. My exponent is 6, and the value, I love this participation that has now reached us. My value is 15,625. And then my next one, what's the base for the next one? 3 to the power of 0. My base is 3. My exponent is 0, and the value of my expression is 1, which is one of the rules that we're going to learn about exponents a bit later on. But by now, it seems like everyone knows that anything to the power of 0 is 1. Okay, for the last one, my base. The base for the last one is 2. My exponent is -1, and my value for the expression is 0,5, which makes me feel like we're using calculators. I see you guys, which is a half. Okay, this is also one of the laws of exponents, negative exponents, but we will get there. Okay, so I'm going to give you guys a few seconds to take a screenshot of this before I move on to the next part of our lesson. This was just a little brain warm up, okay, and a little bit of a revision for the vocabulary that we just learned. From now on, we are applying the product law, or law 1 of exponents. Okay, let's get going. Which of the following options will be the same as -19 to the power of 12 times -19 to the power of 4? So this little dot over here means times, okay? So if I go ahead, what am I doing to my exponents since I am timesing? What am I going to do to the exponents? Well, I'm going to add them. So I'm going to say -12 plus 4. And my new exponent will then be what? -19 to the power of? That is true, Kirini. To the power of -8, which is option 1. Okay. Our brains are warming up, I hope. Our brains are warming up. Okay. Next one. Find x. What is x? If -4.5 to the power of x times -4.5 to the power of 9 equals -4.5 to the power of 11. Okay, so I'm going to write down the left-hand side. It's -4.5 to the power of x plus 9. So if I want x plus 9 to be the same as 11, thank you, then x has to equal 2. Nice. Our brains are warm. I love it. So my option is option number 4. Okay. Great. Let's get going. Hopefully you guys have taken a screenshot. Next, we have 23 to the power of 2n times 23 to the power of 6n. I almost wrote with my red pen. So then it will be 23 to the power of what times plus what? Excuse me. What plus what? 23 to the power of what plus what? Remember, we're still applying law number 1. Thank you, Andile. 2n plus 6n. Can we simplify this? Is it possible to simplify this? Thank you, Leachilwe. 23 to the power of not just 8, 8n. Okay. Great. Next one, we have a -3 to the power of -49 times a -3 to the power of 95. We are still multiplying, so we add my exponents. So this will then give us -3 to the power of -49 plus 95, which means it's -3 to the power of what? -49 plus 95. That is 46. Great. Okay, I feel like I'm going a little bit fast, so I'm going to wait for us to write down quickly. I'm going to wait a little bit so we can write down these notes. Take a sip of water. Thank you, Londeka. Wonderful. Okay. Next. -22 times negative 22 to the power of x plus 7 times negative 22 to the power of 7, okay? So it's going to be negative 22 to the power of what plus what? Let's hear. To the power of what plus what? Negative 22 to the power of what plus what? 7 plus 7 plus x. Nice. Nope. X plus 7 plus 7. Remember, x plus 7 is not the same as 7x. 7x means what? 7x means what, guys? 7x means 7 times x, which is not what we're saying. We're saying 7 plus x. So can we simplify this exponent? We have negative 22 to the power of x plus 7 plus 7. Can we simplify this exponent? Yes, so let's simplify it. Thanks, Leachilwe and Entle. It is negative 22 to the power of x plus 14. Remember, here we are doing like terms, and the only like terms we have is a 7 and a 7. That x does not have a like term, it's just on its own. Okay, that x does not have a 7. Okay, before I move on with these other ones, this is your chance to screenshot, and this is my chance to say thumbs up, thumbs down on what we have done so far. If you are new, if you understand, you give me one of these. Go to reactions and give me this. And if you don't understand, you give me one of these. Okay, I see your reactions. I only have 8 though, and there are 28, 29 of us in here. Okay. I see a little bit more reactions. There we go. Great. Let's take a deep breath before we continue here. Okay. Now, I'm going to move on to these ones. Okay. Now I'm going to move on to these ones where we introduce numbers. How do we work with exponents when numbers are involved? Okay, so that's going to go back to a rule that we spoke about while we were doing integers. So that rule was S and V. Can we remind me again what S and V stands for? The S stands for? What does my S stand for in S and V? Signs. Thank you, Tlale. And my N, numbers. Thank you. And my V, variables. All right, so this comes in very greatly when we are doing what we are doing right now. Okay, so as you can see, we have a bunch of negatives and positives and variables and numbers and that and that. So this is the order which you use to solve these. Okay, so this is my order. So let's start with my signs. I should probably number these because they're just sitting here like I don't know what. So I'm going to number this. I'm going to say A. This was B. This is C. This is D. Oh, we're on D. We are on D. Okay, so let's see what D has for us. It has negative 2A times negative 3A times negative 4B. Do not confuse this with adding. If there were no brackets, then we would be adding or subtracting. But in this case, we have brackets, which mean multiplication. Okay, I'm going to highlight these brackets so you don't confuse them for adding and subtracting. These brackets mean we are multiplying. Okay, now let's start with my symbols. A negative and a negative gives you what? Two negatives give us a positive plus another negative. That's a negative. Okay, we've dealt with my signs. Now let's go to numbers. 2 times 3. 2 times 3 is 6 times 4. Nice. 24. We've dealt with my numbers and we are done. Now we move on to our variables. How many variables can you guys see in this question? Rather, let me say, how many different types of variables can you see? Without duplicating any, how many different type of variables can you see? 2. We have a and we have a b. Okay, so I'm going to deal with the a's first. If there is no exponent, then what is my exponent? If there is nothing there, then my exponent is 1. So for a, it's going to be a to the power of what plus what? They both don't have an exponent, so it is to the power of what plus what? 1 plus 1. And then you have b. So then my final answer is negative 24 times a to the power of, nice, Clary, 2 and b. Okay. Hopefully I didn't lose anyone along the way. Hopefully you were all following me. Okay. Let's see the next one. It's way too soon for a brain break. Let's see the next one. I'm going back to my symbols. We have a negative and a positive. So a negative and a positive are going to give me what type of answer? I'm forgetting to number these again. E. So my answer is going to be negative in this case. Now I have numbers, which is 2 times 4. 2 times 4 is going to give me 8. We're done with our numbers. There are no other numbers. Now, how many different types of variables can we see in this specific case? 3 different variables. What are my variables? Nice. My variables are X and Y and Z. So I'm going to write these down. Actually, I'm going to first highlight them. We have X, we have a Y, and we have a Z. Okay, so it's going to be X to the power of what plus what? Two plus 1 times Y to the power of what plus what? 3 plus 4 times Z to the power of what plus what? 4 plus 1. Okay, final answer, negative 8 to the power of negative 8 times X to the power of 3, Y to the power of 7, and Z to the power of 5. Nice. Nice, guys. Nicely done. Okay, I'm going to close my door because there's a lot of noise outside. While you guys screenshot and think of any questions if you have any. Okay, no questions. Seems we don't have any questions, but it is way too early for our brain break. So I'm going to scroll right past it and I'm going to go to the bottom and we're going to do these. Okay. Now, let's see. How many different bases do we have for this one? Where did I stop numbering? Let's see. E. Let's go with F. Let's go with F. We have 2 different bases, which is N, A, and a B. Okay, so this will equal a to the power of what? A to the power of 3 times b to the power of 4. Nice. We're getting good at this. G. Back to numbers, okay? If they're both positive, then my answer is going to be positive. Okay? 6 times 2. We have a 12 and a m to the power of, nice, Seth, m to the power of 5. Remember, it's 2 plus 3, which is 5. Next. Next is H. Okay. Now we have 2s and 3s and 5s and X's and Y's. I am going to start with which bases do we have? I'm going to start highlighting the bases first. What are the different bases that we have in this case? Give me one of the bases so I can highlight them. X. Okay, we have an X over there and over there. Next, a Y over there and over there. Next, a 2 over there and over there. And my last one, thanks, Caleb, is 3 on its own over there. Equals. So everything is positive, so our answer will be positive. I'm going to start with the 2's. So it's 2 to the power of 7 times 3 to the power of 3 to the power of 5. So 3 doesn't have a partner, it's on its own. So it's just 3 to the power of 5. Okay. Times x to the power of 6 times y to the power of 7. Okay, let's simplify this quickly. What is 2 to the power of 7? How much is 2 to the power of 7? 2 to the power of 7. Yes, Londeka. Hello.
It's 128.
128. Thank
Hello?
you. Yes, I heard that. Okay, and then what is 3 to the power of 5? 243. Then I'm just going to write these the way they are. X to the power of 6, y to the power of 7. So what's 128 times 243? 128 times 243, 31,104. X to the power of 6, y to the power of 7. Do you guys think I would have gotten all my marks if I stopped here? Or actually, if I stopped here? If I stopped in step number 2, would you think I'd get all my marks? Why not? Why do you think I wouldn't get all my marks? Or Seth says yes. Why do you guys think I wouldn't have gotten all my marks? Anyone? Because I didn't simplify. Thank you, Kirani. You always have to simplify. In this case, we cannot simplify, right? We have no idea what x is. We have no idea what y is. So we just have to leave it as x to the power of 6, y to the power of 7. But you cannot leave it as 128 times 243. You have to simplify it. Okay, speaking of which, I suggest you guys make a table for yourselves in your book where you go, okay, you don't have to do 1 because 1 is the same. 1 times 1 to the power of anything will just stay as 1. You don't have to do with 1, but you do it from 2 to the power of 1, 2 to the power of 2, so on and so forth until 2 to the power of 5, and do that until 7. Are we listening? So you have 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. And you know those. Just in case your teacher says no calculators, then you can still figure the answer out. All right. Okay. Let's do this one. I'm going to have to come up with new questions after the brain break because we are burning through these questions very fast. Okay, let's do the next one. Is 3 and -3, are they the same base? Let me hear what you guys have to say. 3 and -3, can we say those are the same base? Tali says yes. Everyone else says no. Are they the same base, guys? Okay, Tali, you're the only one who said yes. I want you guys and Sinyani. I want you to look at this. 3 squared. No, squared is a terrible example because it's going to give you the same answer. 3 cubed and -3 cubed. Okay, how much is 3 cubed? Thank you, Andile. I love that answer. How much is 3 cubed, guys? 27. How much is -3 cubed? -27. So I'm going back to, are these the same? No. So if they are not the same, can we apply law number 1? Are we allowed to say this is 3 to the power of 2 or something? No, do not do that. Okay, they are not the same base. So you just stick to the rule of symbol, number, variable. Just multiply them as if they were 2 different numbers, just like we did here. Okay, so I have a positive and a negative. So my answer is going to be what? What do you guys think? A positive, and a negative. So my answer is going to be negative. That is true. 3 times 3 is 9. And then let's go with my x. So it's going to be x to the power of what plus what plus what? X to the power of what plus what plus what? Nice. -2 plus 3 plus -3. And then my y is on its own, so I'm just going to rewrite it over there. Now, what is this plus minus situation going to cause? This positive negative is going to become a what? A negative. So it's going to be -2 plus 3 minus 3. Why? What's -2 plus 3 minus 3? -2 plus 3 minus 3. Thank you very much, guys. It's a -2y, and that's my final answer. I might as well, never mind. I have 2 more. I thought I only had 1. Thumbs up, thumbs down. How are we feeling about this concept? Yes, Sinyani. You may unmute yourself. Hello. If you're on the phone, then just swipe. Oh, never mind. Let me lower your hand for you. Okay. So I'm hoping that was a thumbs up. Okay, who's going to talk to me quickly for our brain break? Let's have a quick brain break before we get back to it. Here we go. Tali, are you ready? Hello?
Hi.
There we go. Would you rather be reincarnated as a snake or as a shark or an eagle? I don't know why I said snake. Shark or an eagle? Did you say shark? Everyone is saying shark. I'm guessing you guys like water.
Not really. They're dangerous.
Not really, but
They're dangerous.
oh, I can't hear you properly. Your network is shaky. Send your answer in the chat, Lali. I really want to hear what you're saying, why you want to be a shark. Kirini says, I want to be a shark because they're cooler than birds. Wow. Oh, we're dangerous. Eagles are dangerous as well. Eagles are also dangerous. Sharks can't see. Why do you guys have such interesting facts that, like, even I don't know this, and I made these up? Hectic. Wow. Would you rather have a pet python or a pet tiger? This one's going to be interesting. Tiger, python. Guys, I feel like this is a battle I can never win. A python's dangerous. A tiger's dangerous. Like, it's just danger. Danger, left, right, center, everywhere. Danger. Oh my goodness. Wow. Tiger was an easy call. Tlale, oh my gosh, hectic. That took such a dark turn. Wow. And he was like, look, it's better to get a pit bull. I'm not getting either of those. Would you rather go a year without eyebrows or a year without any hair on your head? Like absolutely nothing. So you either have no eyebrows or you have no hair on your head. What do you guys say? No hair, hair. Caleb's like, there is no way. Caleb, do you know how strange you look without eyebrows? Oh my goodness. You look so strange without eyebrows, guys. I hope you guys can actually draw eyebrows, not the stuff that people do. Oh my goodness. Caleb's like, look, my hair keeps my head warm. I would rather go without hair, guys. I actually don't mind having no hair on my head. I don't care. I will rather have no hair. No hair people will not notice. But with eyebrows, yes, with eyebrows, people will be like, something is different. They won't be able to identify it, but they'll know. Wow. Would you rather have it rain every single day, as in thunderstorm every day, or have it be so cold that you cannot spend more than 10 minutes outside? So it's either really freaking cold or it's raining every day, all day. Thunderstorm rain. Oh my goodness, guys, I am so terrified of thunder and lightning. I don't think I would choose that. I would never choose thunder and lightning. I like rain, but thunder and lightning are a problem for me. Like, it's fine if it rains silently, that I don't mind. But thunder, I guys, I'm sorry. I will be unable to can that one. Mm-mm. At all. I wouldn't be able to, guys. As soon as you move in the house, I'm like, nope, nope, tap out. I'm done. I'm gonna go back to my bed and do nothing. Yeah, the cold is better for me as well. And the last one, guys, would you rather eat moldy, rotten cheese or drink water from a rain puddle outside? Like it's been raining, would you rather just or eat rotten cheese? Whoever said cheese, you are brave. Oh my goodness. Oh my goodness. When I say rain, guys, I don't mean you put a cup outside. I mean there is a puddle on the floor. So you must scoop that up and drink it. Wow. You guys are like, I stick by my choice. I stick by my choice. Okay. Okay, guys, let's have a nice stretch. Let's have a good stretch so we can keep going. I only have 2 questions left, but I have many more in my brain, so I will make them up. Worry not. Okay, let's go on to J. Let's go on to J. Right, we have a negative 4x cubed y to the power of 9 times negative 5xy squared. Okay, a negative and a negative is going to give us what? A negative and a negative will give us a positive answer. And 4 times 5, 20. And then x to the power of 4 and y to the power of 11. Nice, quick and easy. Okay, this time we have 3 negatives, a negative and a negative and a negative. Oh, I have another question. Ha, I keep surprising myself. 3 negatives are going to give us what answer? A negative. Let's start with my numbers. We have a 6 and a 10. 6 times 10. 60. Then we have x. X to the power of what plus what plus what? 12, 13. Seth's brain is working. 13, yes, because remember we have a 1 plus 7 plus 5. And then y to the power of 3. Okay. And now I'm on my last one. Okay. Positive, negative, negative. My answer is positive, yes. 5 times 4, again, 20, m to the power of 7, 8, 9, 10, 11, and n to the power of 10. Nice, guys. Let us make more questions. Okay, and I need to move this writing pad closer because my handwriting is looking more and more terrible. Let me do like so. Okay. Okay, let's see. Negative 2xy. Okay, let's go for it. A negative and a negative and a negative. That's 3 negatives. So my answer is going to be negative. Okay, I have a 2 times 5, which is 10 times 7, 70. And then I have x to the power of what? X to the power of negative 2. Beautiful. Y to the power of y to the power of what? I have a negative 11, a negative 12, a negative 5, negative 13. What's 2 plus 4? 2 plus 4 is 6, minus 11. Nice, and J, negative 5. So it's y to the power of negative 5, and then z to the power of negative 2. Okay, let's make life a little more interesting. Negative 3m squared n to the power of 4 times Okay, what's going on over here? Without using the law, if you know the law, that is fabulous. But if you didn't know the law of exponents that deals with this, what would you guys have done in a test? Achilles says bed maths. Okay. How would you solve this? Okay, maybe 4 is a little bit excessive now. Let me make it a 2. That 2 means we are timesing what? So if you didn't know the law, Senyane, if you didn't know the law, what would you do? Okay, 2 people have said 2 times 2, so I'm not sure which one are we speaking about. Does this not mean you're multiplying your bracket out by itself twice? Do you guys remember that? So it's the same as saying negative 3m squared. I say m and I write n. M squared n times another negative 3m squared n times the rest of them, negative 2m cubed n to the power of negative 2 times m negative 7n7. Great. Does this not look like what we have been doing? So if you didn't know the law of exponent that deals with a power to a power, you would just write it out. And then it looks exactly like law number 1, which means we're going to say negative times the negatives gives me what? A negative times next is a positive times another negative. A negative times a positive. Still a negative. Okay, 3 times 3 is 9 times 2, 18. We've dealt with the numbers. Now let's deal with m. So it's m to the power of 2 plus 2 plus 3 plus negative 7. So let me write that down. 2 plus 2 plus 3 plus a negative 7. And n to the power of, we said where there's nothing there, there is a. There is nothing there, we have a 1. So we have 1 plus 1 there. A 1 plus another 1 plus a negative 2 plus a 7. Okay. Now, this plus minus situation gives me a what? There's another one over there. Positive negative situation gives me a negative. So it's negative 18m to the power of 2 plus 2 plus 3 minus 7. And n to the power of 1 plus 1 minus 2 plus 7 equals negative 18 and m to the power of what? 2 plus 2 plus 3 plus minus 7, that's 0. And n to the power of what? 1 plus 1 minus 2 plus 7, 7. Nice, Londeka. This m to the power of 0, anybody know our rule? Anything to the power of 0? Nice, Kirini. Oh, this was actually a really lovely question. By mistake. I promise you I didn't think ahead of this. So it's going to give us negative 18 times 1 times n to the power of 7, which is back to numbers. A negative 18 times a positive 1 gives us a negative 18 n to the 7. What a beautiful sum. I should make them more often. Okay, there you are, screenshot house. Let me do this so you can screenshot this one as well. That is where I'm going to end my lesson for today. I will see you guys on Thursday. Can I have a final thumbs up or thumbs down or a question? Thumbs up, thumbs down, or any questions that you guys might have. I will see you guys on Thursday. Okay, have a lovely evening. It's evening. Lovely evening. Yes, you guys are maths geniuses. On Thursday, not today, Andile, there isn't. I haven't set up polls yet. Okay. Do you have any feedback, Andile? You can DM me if you do. If I was too fast or too slow, you guys can direct. Do we end up doing financial maths? Yes. I'm not sure it's in term 1 though. I don't think so. So on Thursday, we are doing law number 2, okay, which is the quotient rule. What does quotient mean, guys? What does quotient mean? Seth says a bit fast. Okay, Seth, noted. Quotient means what? Divide. Yes, it does, Roleboa. So we will be combining division of exponents, well, terms with exponents, with multiplication. So we will be adding and subtracting exponents. Okay,